Here we'll be calculating the pH. We'll be calculating the ionization constant, Ka, of hypochlorous acid. Hypochlorous acid, being a very weak acid, ionizes only partially in aqueous solution, as illustrated in the ionization equation. So we have hydrogen ion plus its conjugate base, the hypochlorite ion. Now we want to recall that the Ka expression is concentration of hydrogen ion multiplying concentration of chlorate ion divided by the concentration of hypochlorous acid. At their equilibrium concentration. So we are given the pH of the hypochlorous acid as 4.23. Now, our previous class we learned that pH is negative logarithm of hydrogen ion concentration. So we can work out the concentration of hydrogen ion in the hypochlorous acid. So 4.23 equal negative log to base 10 hydrogen ion concentration. So this turns out to be, when you write in the inverse indices format, 10 to the power of negative 4.23 equal concentration of hydrogen ion. So evaluating this, so the concentration of hydrogen ion is 5.89 times 10 to the power of negative 5 mole per liter. Next, we want to generate an ice table The ice table comprises initial concentration, change in concentration, and equilibrium concentration of the chemical entities in this problem. So hypochlorous acid being the reactant, the concentration will just be in the first column, and the concentration of hydrogen ion, and then finally the concentration of hypochlorite ion. Now, initially we were told that the concentration of the hypo is 0.1 mole per liter. So we can have 0.10 here. And since the acid is very weak, there was no initial concentration of the hydrogen ion and the hypochlorite ion. Then during the change in concentration, minus X has disappeared here, plus X has appeared here, plus X has appeared here. And we are told that based on the calculation we found for the hydrogen ion as equilibrium, we have 5.89 times 10 to the power of negative 5 for the hydrogen ion concentration, while for the equilibrium concentration of hypochlorous acid, 0.10 minus X. For the equilibrium concentration of hypochlorite ion, we have X as well, since nothing was given. But we can see that the concentration of hydrogen ion takes the value of X, and that is as good as 5.89 times 10 to the power of negative 5 mole per liter. And that gives the concentration of hypochlorite ion as well, since it has a value of X as 5.89 times 10 to a negative 5 mole per liter. You can get the equilibrium concentration of the hypo. Equilibrium concentration of the hypo based on the ice table is 0.1 minus X. So when we substitute the value of X, 0.10 minus 5.89 times 10 to the power of negative 5, still in mole per liter. So when we find this difference, 0.0999 to 4 decimal place. So we have 0.0999 mole per liter. Now we are ready to calculate the Ka of the hypo. We want to remember that Ka is the product of concentration of hydrogen ion, hypochlorite ion divided by equilibrium concentration of the hypo itself, So we have 5.89 times 10 to a power of negative 5, multiplying 5.89 times 10 to a power of negative 5 divided by 0.0999. So on evaluating this, so this gives a value of 3.47 times 10 raised to power minus 8. Since it's just a constant, we can do it with the units. So the K of hypochlorous acid with a pH of 4.23 is 3.47 times 10 raised to power minus 8.